Hello everyone, so in this video we will be discussing the application of the derivatives of trigonometric functions. So having discussed the trigonometric functions, the derivative of the trigonometric functions from the previous sessions that we had, so now we can already try to solve some problems or some worded problems that includes trigonometric functions. So we have here our first example. We have a trapezoidal gutter is to be made from a strip of metal 22 inches wide by bending up the edges. If the base is 14 inches wide, what width across the top gives the greatest carrying capacity? If this is our strip that is 22 inches wide, and if we bend up the edges, the base will be 14 inches. So meaning to say, if this side will be bended here and as well as here, the size or the dimension of the base now will be 14 inches. This one. So as you can see, it will now form like a trapezoidal gutter. So like this. Since we already bended it. And again, this from this strip is 22 inches wide. So meaning to say, if we have 14 inch left, the 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 measurement of the sides that we have bended is 4 and 4, right? So this is 4 inches. Okay. This is 4 inches. So we now form a trapezoidal gutter. So if you can observe again, we can divide this into 3 areas. We have one. This one is a right triangle, which means this is the area 1. And since area 1 is just the same as here, so this would also be our area 1. And this one will be area 2. So from here, this is the angle that we have. This one as well will be an angle. And we know that the measure of this one is 14 inches. But we don't know the measure of this one and this to here and here. So let's say this is x, since this is horizontal. So we have to find the width across the top. So meaning to say we need to find how much or how long is this one in the top. That gives the greatest carrying capacity. So now, what can we do is we have to formulate our equation. So from the area, since we are looking for the greatest carrying capacity, so we need to look for the area. And since our figure involves two areas, which is the area for the right triangle and the area for the rectangle. So we have here the area. The total area is equivalent to the area in 1, which is 2, because we have two right triangles. So let's say that's times 2 plus the area 2. And we know that the area 1 is 1/2 base times height. We have 1/2 base times height. This one is our y. This is also our y. And then for the area 2, the area for the rectangle is length times width. So we have length times width. And then what we should do now is we have to figure out what are the equivalent b and h and l and w. So from here, let's focus first on the right triangle. So we have here the right triangle or the area 1, which is also similar to this one. So from here, we have our hypotenuse as 4 inch. This is our y and this is our x and this is our angle. So in order for us to find the value of the x and the y, so base is the x, b is equivalent to x, right? And height is equivalent to y. But we need to find the value of the x and the y. So in order for us to find the value for the x and the y, we need to use the SOHCAHTOA. So if you can remember, we have SOHCAHTOA. So we need to find a trigonometric functions that would involve, in order for us to find the x, that would involve the x and the 4. We should involve the unknown values. Kailangan yung gamitin natin is yung mga known values lang. Kailangan pag gumamit tayo ng trigonometric functions is one variable lang yung unknown. In which, in this case, dapat si x lang ang unknown. So, para ma-involve natin si x and si hypotenuse, the x here is the opposite, right? And this is the hypotenuse. So, meaning to say, we have to use so, or the sign is equivalent to opposite over hypotenuse. So, meaning to say, this one, para mahanap natin si x, this is sine theta is equivalent to opposite, which is x, over 4 for the hypotenuse. So, in order for us to get the x, or to isolate the x, we can multiply both sides by 4. So, this would be 4 sine theta is equivalent to x. So, meaning to say, this is now the value for our x. Now, for the y, kailangan natin magamit si 4 and si y. Because kung gamitin natin si x and si y, dalawa na yung unknown. So, kailangan natin gamitin, or kailangan natin i-utilize yung trigonometric functions that would involve the hypotenuse and the adjacent. And that is cosine. Cos is equivalent to adjacent over hypotenuse. So, meaning to say, cosine theta is equivalent to adjacent, which is the y, over hypotenuse, which is the 4. So, that means we have 4 cos theta is equivalent to y. So, the value of our y is 4 cos theta. So, that means that from here, we can substitute that here. The base is the x, which is 4 sine theta. And we also have the height, which is the cos 4 cos theta. And then afterwards, we have to find now the area 2. So for the area 2, it's length times width. So for the length and width, we have, this is 14. And this is y, which is the unknown. This is again the area 2. So this is, so itong part na to, yung hinahanap natin, yung area 2. Okay? So from that, we know that the area for the rectangle is 14 times y. So it's 14 times y, which is 14y. So meaning to say this one is equivalent to 14y. Now, after we have already the values for each areas, we can now substitute that to our total area. So from here, from the total area, from this equation, we have A is equivalent to 2 because dalawa yung A1 natin, dalawang area 1. So that's 2 times 1/2 times 4 sine theta times 4 cosine theta. So, makancel si 2, cancel si 1/2. And then, we have plus the area 2, which is equivalent to 14y. So, for the area, we now have 4 sine theta times 4 cosine theta plus 14y. So, this is now our equation. But from the earlier, as we know, ang value ng y natin is 4 cos theta. So, meaning to say, we can replace our y by trigonometric function, which is 4 cos theta. So, this is now our equation. Now, since there are common terms between the terms that we have, we can factor that out. So that gives us 4 cos theta times 4 sine theta. Since 4 cos theta is common to both terms, so we'll just factor that out. So that gives us this one as our area. So this is now our equation. So after we got our equation, we can now derive it. So the derivative of A with respect to theta. So we can use the product rule for this one. We have u dv. So u times derivative of v, which is 4 cos theta, plus v times the derivative of our u, which is negative 4 sine theta. So again, this is our u, and this one inside the parenthesis is our v. So that's why this is the derivative of our area. So simplifying this, we have 4 cos theta times 4 cos theta. That gives us 16 cosine squared theta. And then the other term, we have 4 sine theta times negative 4 sine theta. So that gives us negative. We'll erase this one. We'll replace that with negative sine theta. Sine squared theta. 16 sine squared theta. And then we have 14 times negative 4. That gives us negative 56 sine theta. So after we have derived and simplified, so we can now equate this into 0. So equating this to 0, that will give us this. Afterwards, we have to find, so if you can recall, the value of our x is equivalent to 4 sine theta, and the value of our y is equivalent to 4 cos theta. And kailangan nating hanapin yung value ni x. So, kailangan, para mahanap natin yung value ni x, kailangan natin mahanap yung value ni sine theta. So that we can substitute that to this equation. So we can find the x. And if we already find the x, then we can already find the width across the top. So from here, that being said, kailangan natin i-change yung mga trigonometric functions in our equation into sine theta so that we can find the equivalent of the sine theta. So, as you can see, meron tayong isang cosine dito sa ating equation. So, we can find some identities that would replace this into sine. So, if you can remember, we have an identity that the cosine squared theta is equivalent to 1 minus sine squared theta. So from that, we can replace that here, in which would give us 16 times 1 minus sine squared theta minus 16 sine squared theta minus 56 sine theta. So as you can see, all our trigonometric functions are in terms of sine, so that it would be easy for us to find the value of x. We don't need to find the value of y because we are just only looking for the width across the top. So simplifying this, we have 16 minus 16 sine squared theta minus 16 sine squared theta minus 56 sine theta. And then arranging this into the highest exponent, so we have negative 16 minus 16, that is negative 32 sine squared theta minus 56 sine theta plus the constant 16. So again, we only combine like terms, and arrange it according to the exponent. So now we can already factor this so that we can find the equivalent of sine theta. So sine theta, if you have factored this using your calculator, that is equivalent to -2 and positive 1/4. So there is no such term as negative angle or negative sign. So meaning to say we'll not use the -2. That being said, our sine, or the sine theta now, is equivalent to 1/4. So after we got the value for the sine theta, we can now substitute that to for the equation of the x so that we can find the width of the top of our trapezoidal gutter. So x is equivalent to 4 sine theta, in which our sine theta is equivalent to 1/4. So meaning to say our x is equivalent to 1. So x is equivalent to 1. So that means the width across the top is, we have the x, we have 14, and the x, right? So meaning to say we just have to add up all of this. So we have 1 plus 14 plus 1. So that gives the width of the top is equivalent to 16 inches. So our final answer is 16 inches. Okay, so we have another example here. A wall 10 feet high is 8 feet from a house, 8 feet away from a house. Find the length of the shortest ladder that will reach the house when one end rests on the ground outside the wall. So, materializing that example, let's say this is our 10 feet wall that is 8 feet away from the house. So again, this is 10 feet. And that is 8 feet away from the house. So let's say this is 8 feet. And let's say this is our house here. This is the house. So it says that we have to find the shortest ladder that will reach the house when one end of the ladder rests on the ground outside the wall. So let's say this is our ladder and this is the house, alright? So this is our house here. So that being said, we need to find again the height or the length of the ladder. So by similar triangle, we can say that this one here, the length of this one is also 8 because it is parallel with this one. And this one is unknown since we don't know the height of this one from here. But we know that the height of this is 10 feet because it's parallel with this one. And then for this one, for the other one, we don't know the dimension of this one, so this is our x. But what we need to find is the length of this ladder. So let's say that is our ladder. We don't know the dimension of the ladder or the length of the ladder. So in order for us to find the length of the ladder, if you can see, this is a big triangle, big right triangle. This one is a triangle, right? So that being said, we can use the formula of a Pythagorean. So the Pythagorean formula is the ladder, which is the hypotenuse. So that's L squared is equivalent to a squared plus b squared. So let's say this is our a squared. So that is a plus x squared. And then for the b squared, we have y plus 10 squared. Okay, so again, this is from the Pythagorean formula, which is c squared is equivalent to a squared plus b squared. In order for us to find the value of the x, we can have this as our angle. We have here our angle and here as well. So in order for us to find the value of the x, we can have it as here, x. This is 10. This is still unknown. So this is the angle, theta. So if you can use the SOHCAHTOA again, SOHCAHTOA. we need to use the opposite in and the adjacent. So that means that we have to use the tangent. So tangent theta is equivalent to opposite, which is 10, and the adjacent, which is x. So to isolate the value of x, we can multiply both sides by x. So that gives us x tan theta is equivalent to 10. So to isolate more the value of x, we have to divide both sides by tan theta. So that means the value of our x is 10 over tan. And in order for us to find the value of the y, we can use this as our basis, this triangle, the y, the 8, and the angle. But we don't know again the hypotenuse. So we can use TOA once again. So we have tangent theta is equivalent to opposite over adjacent. So that gives us 8 tan theta as our y. So this is now the values that we have to do or that we have to use. So after that, we can replace or substitute now the value of the x and the y to our equation, to our L squared. So that gives us L squared is equivalent to 8 plus x, in which the value of our x is 10 over tangent theta squared plus y, which is 8 tan theta plus 10 that is squared. We can simplify this one so that we can easily derive this later on. So we have 8. Since this is in fraction, we can find some equivalent reciprocal identity that we can use so that we can have this, we can remove the fraction. So if you can remember, cot theta is equivalent to 1 over tan theta, right? So that means that we can replace 1 over tan theta by 10 cotangent theta. That is in squared plus 8 tangent theta plus 10 squared. So after that, after we have simplified our equation, we can now derive this one. So derivative of L squared is 2L, derivative of L with respect to theta. Derivative of this, power rule, we have 2 times 8 plus 10 cotangent theta squared times the derivative of our cotangent 10 cotangent theta, which is negative 10 cosecant squared theta, and the other term, which is 2 times 8 tangent theta plus 10. And then find the derivative of 8 tan theta. That gives us 8 secant squared theta. So afterwards, we have to equate this one into 0. So that gives us 2 times 8 plus 10 cotangent theta squared times negative 10 cosecant squared theta plus 2 times 8 tangent theta plus 10 times 8 secant squared theta is equivalent to 0. So after we have equated that to 0, we can now simplify this so that we can find the value of our tangent, since we need to find the value of our tangent because our x and the y are in terms of tangent. So in order for us to find the ladder or the length of the ladder, we have to find the x and the y. And in order for us to find the x and the y, we need to find the value of our tangent theta. So that being said, we need to replace all, or we need to find some identities that would replace all the trigonometric functions here that is not in tangent form. So since some of these trigonometric functions are not in tangent, so we have to find some equivalent so that this would make us, so that this would give us a tangent trigonometric function. Afterwards, again, that being said, we have to convert all the trigonometric functions into tangent. So from here, we can divide both sides by 2 since we also have 2 on the other term, so we can cancel this already. assuming that we have divided it by 2. Anyway, if you divide 0 by 2, that would still give us a value of 2. So from here, we can replace 10 cot theta by its original value, which is 10 tangent theta squared. And for this one, negative 10 cosecant squared can be replaced by the Pythagorean identity, which is equivalent to 1 plus cotangent squared theta plus the 8 tangent theta plus 10. And for the secant squared, we can replace that by the Pythagorean identity, which is 1 plus tangent squared theta. So we almost have all the trigonometric functions converted into tangent. So we only have one left, which is cotangent squared. So rewriting all of this again, we have tangent theta squared times negative 10 times 1 plus 1 over tangent squared theta. Again, we use this reciprocal identity to convert cotangent into tangent, plus 8 times tangent theta plus 10 times 8 times 1 plus tangent squared theta. That is equivalent to 0. So as you can observe, all of our trigonometric functions were already converted to tangent. So in order for us to easily find the value of our tangent, we can calculate this one replacing tangent theta by x. So tangent theta by x. So that gives us 8 plus 10 over x squared times negative 10 times 1 plus 1 over x squared plus 8 x plus 10 times 8 1 plus x squared. So that we can easily again substitute. We are just doing this so that we can easily substitute it using our calculators. Then if you can find the value now, the tangent theta, this one, if you have already substituted this in your calculator, shift solve, you can get the value of your tangent theta, which is equivalent to 1.0772. So that being said, we can now substitute the value of our tangent theta to, so substituting the values that we have for tangent theta here in our equation, we have L squared is equivalent to 8 plus the value of x, which is 10 over tangent theta squared, plus the value of y, which is 8 tan theta plus 10 squared. And again, we know that tangent theta is equivalent to 1.0772. So that gives us L squared is equivalent to 8 plus 10 over 1.0772 squared plus 8 times 1.0772 plus 10, and that is squared. So in order for us to find the L or the value of the ladder, so square root both sides. So that gives us L is equivalent to square root of 645.33, which is approximately equivalent to 25.40 feet. So that being said, the length of the shortest ladder is 25.40 feet. So this is now our final answer. So I hope you learned something from this video. I am assuming and I am hoping that you will try to solve some other related problems in order for you to be prepared for your examinations. So that's it for this video. Thank you everyone.